Good morning, students. Today I am going to revise the gravitation chapter. You listen very carefully. If you have any query, write in the chat box. Okay, students, are you listening my voice clearly? I am going to revise the gravitation chapter. You listen very carefully. If you have any query, write in the chat box. Okay, students. First, gravitation. Our chapter name is the gravitation. What is gravitation? What is gravitation or the gravitational force? Can anyone write the definition of gravitation? What is the gravitation? Gravitation is the force of attraction between any two objects. The attraction, force of attraction between any two objects. The force of attraction between any two objects is called as gravitation or the gravitational force. It is called as a gravitation, or we can also call it as the gravitational force. Gravitational force. Let us see here. Any two objects in the universe attract with each other. This gravitation is firstly observed by the scientist. For example, we know that the Newton, right? The Newton is sitting under the tree. Okay, sometime the apple fall down, right? He thought, why the apple will fall down? Why it not goes up? Why it is fall down on the surface of earth? He thought like that. That means this earth is attracting this object apple towards its center of earth, right? Then later he studied whether the earth attracts only some objects or earth attracts all the objects, and finally he concluded that any two objects in the universe are attracted with each other, not only apple and earth, not only person and that apple, earth and earth, then sun and other planets and stars and everything, any two objects in the universe, even between two persons also, there is some attraction force is there, that is called as the gravitational force. This is generated due to the mass, right? And next, the we know that the sun is revolving, that the earth is revolving, and all the other planets also revolving around the sun. Earth and all the planets revolving around the sun, that is also because of gravitational force. Because of gravitational force is the attraction force. Sun attracts the earth towards its center. That attraction force serves as a centripetal force. Actually, to maintain any body, some force is required, that is called as the centripetal force. Do you know the definition of the centripetal force? Anyone can write the definition of centripetal force. What is centripetal force? Centripetal force is called as the center seeking force. Okay, the force which acts towards center of towards center of circle, towards center of circle is called as centripetal force. Centripetal force is the force which acts towards the center of circle. Okay, it acts towards the center of the circle. Now, for example, this is your hand, okay, and now you are rotating one stone. This is a string, and at the end of the string, we are connecting one stone, and you made this stone to rotate in the circular path like this, right? Here what happening, the stone is moving along the circular path. Okay, then for example, if you leave this stone at any point, if you leave this stone at any point, for example, if the string breaks at here, this is the string, okay, this is the string, okay, this is the stone, and you are making the stone to rotate in circular path, right? For example, at any instant, if you left free the stone, if you release the stone will go in straight, that means some force. Actually, when you release this one, when you left free the string means thread. Okay, what you're doing it here, this is a stone, you are connecting to a thread and you are making the stone to rotate in the circular path. At that moment, your hand will apply some force toward the center of the circle. That force is called as the centripetal force. For example, if m mass of object moving with speed v, okay, m mass of object, moving along a circle of radius small r, m mass of object moving along a circle of radius small r. 1 minute. कर दीजिए, लाइब्रेरी को भी साफ करने के लिए बोल रहे हैं, लाइब्रेरी का खाली झाड़ू कर दीजिए, उसके बाद हम लोग शुरू करेंगे, मेरा क्लास के बाद मेरा शुरू करेंगे, खाली लाइब्रेरी झाड़ू करना है, उसके मेरा क्लास खत्म होने के बाद उधर जाके ये वाला क्लीन करेंगे, उसको ज्यादा टाइम लगेगा। ऊपर ना, नहीं इधर आउटर लैब, वो नीचे वाला, हाँ उसको साफ करना है, तो कर दें, उसको ज्यादा टाइम है, उसको साफ करना है, पानी से करना है एंड कपड़ा से टेबल को धोना है पूरा। को कलेक्टर इना स्टार्ट करने के लिए आ रहा है परसों। आगे तो इधर करें, अभी उधर करते तो इधर करें, नहीं तो उधर शुरू करते तो शुरू कर दीजिए उधर, कोई दिक्कत नहीं। इस दोनों में कोई एक होगा, हाँ ऐसे ऐसे ओपन करके कहा भी मत जाना है, उसमें बहुत सामान है, नहीं तो अब अभी लाइब्रेरी कंप्लीट करिए, उसके बाद मैं बैठेंगे। Over the center of the circle. Here, the centripetal force formula is the mv square by r. You remember it. The centripetal force formula is mv square by r. Here, m is the mass of object which is moving along the circular path. M is the mass of object which is moving along the circular path. M mass of object moving along the circular path. Okay, right? Students, is it clear? M is the mass of object and v is the speed of object. Okay, and r is the radius of object. This is the centripetal force. What this centripetal force will do? The centripetal force makes an object to move along a circular path. To maintain any object along the circular path, the centripetal force is necessary. To maintain any object along the circular path, to move any object along the circular path, what force is required? Centripetal force is required. Centripetal force makes an object to move along a circular path. Okay, if centripetal force acts toward the center of the circle, right? Toward the center of the circle. If this force missing, for example, if your hand is applying the centripetal force and making the stone to rotate along the circular path. If the centripetal force miss, that means if the string breaks, thread breaks, then at the moment the stone never continue in the circular path. That means to maintain any body in the circular path, to move any object along the circular path, some force should be necessary to which acts toward the center of the circle. That force name is the centripetal force. Centripetal force is the force which acts toward the center of the circle. It makes the object to move along the circular path. But to rotate any object along the circular path, this force is necessary. This is called the centripetal force. Okay, right, students? Do you have any doubt? And you can write in the chat box. Next one is the universal law of gravitation. What is universal law of gravitation? Universal law of gravitation. This is the Newton gave this law, universal law of gravitation. According to Newton's universal law of gravitation, what is that? Any two bodies, okay, every object in the universe attracts the other objects. Okay, every object attracts other object with some force. This force is directly proportional to the this force is directly proportional to the directly proportional to the product of masses, product of masses, and inversely proportional to the square of distance between the particles. I will explain this one very carefully. You have to hear distance between two particles. Newton observed that any two bodies in the universe attract with each other. Correct? Newton observed that any two objects in the universe attract with each other. Every object attracts the other objects with some force. This force is directly proportional to the product of masses and inversely proportional to the square of distance between them. Distance between them. What is this? I will explain clearly. You have to listen. Right? This is the first object whose mass is capital M. Okay, and this is the another object whose mass is a small m, and between these two objects there exists some force. Okay, there exists some force. That force is the, okay, look at here, this is the distance between the centers of two objects. The distance between the centers of two objects we can consider as the small r, and this capital M attracts the small m towards its, and the small m also attracts the capital M towards this. Both are attract with each other. This, according to the Newton universal law of gravitation, the force is, attraction force is between the two objects is directly proportional to the product of masses. Product of masses are what? Capital M into small m. Okay, or m1 into m2 also we can write, no problem. And inversely proportional, this force is inversely proportional. Inversely means in denominator we have to write. This is the product of masses of two objects. Force directly proportional to product of masses. Force inversely proportional, in denominator we have to write. Force inversely proportional to square of distance. When you combine both of them, then we will get, right, this is considered as equation 1 and equation 2. From equation 1 and 2 we can write, we can combine both of them. When we combine them, then we will get as F proportional to capital M into small m by r square. When the proportionality is removed, we will get a constant, that is capital G into capital M into small m by r square. This capital G is called as the universal gravitational constant. When the proportional, you combine the both of them, you will get this. When the proportionality symbol is removed, we will get a constant. That constant name is the universal gravitational constant. Universal gravitational constant. This is the name of the constant. In any time, if you remove the proportionality symbol, you will get a constant. Here the constant is capital G. This is the Newton's universal law of gravitation. According to the Newton, force between any two objects. For example, if you want to find out the force between the two persons, you write the capital G value, first person mass, second person mass, and distance between the two masses. Distance with the two persons. That means we can, by using this formula, we can find out the force between any two objects in the universe. Understand, students? Is it clear? Whether my voice is appearing clearly or not? If you have any query, write in the chat box. Okay, students? Right. And the next, let us go for the continuation. And I am going to erase this. If you have query, you write in the chat box. Here we got, according to universal law of gravitation, we got is the force between any two objects formula we got. That force between any two objects formula is what? Force between any two objects formula we got is force between any two objects formula we got is F is equal to capital G into capital M small m by R square. Okay, students, is it clear? Now we are appearing now. Is it clear now, students? Is it clear? Students, is it clear? Now we are appearing now. Is it clear now, students? Okay, students. Then according to universal law of gravitation, there is a mass capital M and another one is a small m. There is some exist force between them. That force is directly proportional to the product of masses. Capital M into small m is the product of masses, and force is directly proportional to the product of masses. Okay, if product of mass is more, the force is more. Force inversely proportional. Inversely means this is a small r. We have to write in the denominator. Inversely means inversely proportional to square of distance between the two objects. If you combine both of them, we will get this one. Here capital G is a one constant. The capital G formula is, from that capital G formula if you want to write, okay, we will get like this, because we will take r square to left side, capital M into small m to left side, we will get the capital G formula is like this, right? Now capital G unit is what is SI unit of capital G? SI unit of G, SI unit is the force unit is Newton, distance unit is meter square, capital M mass unit kg, and small m is also kg into kg square we will get. And capital G have some value. You remember its value as 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the value of the capital G, you should remember. Okay, this is about universal law of gravitation. And next, let us go for the another topic. What is acceleration due to gravity? What is acceleration due to gravity? Acceleration due to gravity. What is acceleration due to gravity? Acceleration due to gravity means, okay, gravity means earth. Okay, earth, due to the earth, if any object acquires the acceleration, that acceleration is called as acceleration due to gravity. That is nothing but acceleration of freely falling body. Acceleration of freely falling body. Acceleration of freely falling body due to gravitational force. Acceleration of freely falling body due to gravitational force is called as acceleration due to gravity. Acceleration due to gravity is what? Acceleration due to gravity is the acceleration of a freely falling body due to gravitational force. It is called as acceleration due to gravity. Okay, then I will explain this one very clearly. You have to listen, okay, with the patience. If you have any query after the explanation also, then you write in the chat box. Okay, okay, students, let us start the acceleration due to gravity. What is acceleration due to gravity? You know acceleration formula previously in the motion chapter we discussed the acceleration. What is acceleration? Acceleration is nothing but okay. I will erase total. Is better. You see here, Acceleration of freely falling body due to gravitational force. Okay, acceleration of freely falling body due to gravitational force is called as acceleration due to gravity. I will explain this one. You listen very carefully. This is the earth. Okay, this is earth. That earth center is this one. Earth mass we can take as a capital M. And this is one of the object which is just above the earth surface. This object mass is the small m. Small m is the mass of object. Okay, mass of object is the small m. Small m is the mass of object. Mass of object. And capital M is the mass of the earth. Mass of earth. Let us see here. This object is freely falling now, right? With some acceleration. Okay, when you left free this object, its initial velocity is 0. When you left free the object, if you release the object, this object will be fall down. While falling, its velocity is increases, right? That means it is acquiring the acceleration. Acceleration is what? Change in velocity by time. While falling this object, its velocity changes. That's well. Acceleration is the rate of change of velocity. Acceleration of freely falling body due to gravitational force. Why it is falling down? If any object is left free at certain height from the ground, it will fall down. If you left free any object from the ground, it will fall down. Because of the gravitational force, it will fall down, right? That means the gravitational force, due to the gravitational force, this object acquires some acceleration. That acceleration is called as the acceleration due to gravity, right? Now I want the acceleration due to gravity on surface of earth. For example, it will fall down on the surface of earth. At here acceleration due to gravity we can consider as small g. I want to find out. Then for that, how we can find out the acceleration due to gravity, right? For that, relation between the small g and capital G we required. Relation between small g and capital G. Okay. What is small g? Acceleration due to gravity, right? Okay. We will write here. Consider an object. Consider an object of mass small m is on surface of earth. Okay, that is the on surface of earth of mass capital M and radius capital R. Then what is the formula for the gravitational force according to Newton's universal law of gravitation? The gravitational force formula according to universal law of gravitation. According to universal law of gravitation, can you tell? According to universal law of gravitation, what is the formula for the gravitational force? That formula is F is equal to capital G into force between these two objects. Between these distance is capital R, right, from the centers. And this object, one object mass capital M and other object mass is small m. Then the force formula we write is capital G capital M into small m by capital R square we write. This is equation 1. Okay. And according to Newton's second law also we write the force formula. According to Newton's gravitational force on object I want. Okay. According to Newton's second law, if you write, right, according to Newton's second law, universal law of gravitation also given by the Newton only. According to Newton's second law, F is equal to ma we write, mass into acceleration. But acceleration due to gravity, acceleration is the acceleration due to gravity. That is denoted acceleration due to earth. Gravity means earth. Okay, that is called as acceleration due to gravity. A becomes the G. These are the force on object in two formulas are there. When you combine both of them from equation 1 and 2, we will get like this. What you will get? Left sides are equal, both are for the force on the objects only. We write like this. That is, from equation 2, mg we write left side, mg, and on the right side we write as g capital M small m by capital R square we write. This is small m cancel. And finally we will get the small g as capital G capital M by R square. This is the formula to find out the acceleration due to gravity on surface of earth. What is the small g here? Small g is the acceleration due to gravity on surface of earth. Acceleration due to gravity on surface of earth, on surface of earth. This is the formula for the acceleration due to gravity. Okay, and what is the value of acceleration due to gravity on surface of earth? I'm going to erase this. Value of acceleration due to gravity. Value of acceleration due to gravity. Acceleration due to gravity on surface of earth. On surface of earth. What is the value of acceleration due to gravity on surface of earth? G on earth I want to find out. Very simple to know this G value. You know this F formula is what? Force between the two objects formula. Capital G, capital M, small m by r square. Is it right? In this, Gm by r square is the mg. This we can also write as ma or mg, small m a or mg. This a is the gm by r square, small m into a, right? That is acceleration due to gravity. I want the value of acceleration due to gravity. Okay, this is considered as the earth. This is the earth. Earth radius is capital R. Okay, and here acceleration due to gravity I want. Acceleration due to gravity on surface of earth, right? Earth mass we can take as a capital M. Now, acceleration due to gravity on surface of earth formula is what? Just now we derived acceleration due to gravity. Is it right? Acceleration due to gravity formula we derived on earth I want. Okay. Then the G formula is capital G, capital M by capital R square. Right? And here capital G value you know, but capital G is the universal gravitational constant. Its value is 6.67 10 to the power of minus 11 Newton meter square per kg square. And capital M is the mass of the earth. Mass of earth. Mass of earth, you remember its value. Capital M is equal to 6 into 10 to the power of 24 kg. And the radius of the earth is the 6400 into 10 to the power of 3 meters. Okay, right? 64 into 10 to the power of 5 we can also write. Okay, this you values you substitute and you will get the G value. Small g is equal to capital G value is 6.67 into the power of minus 11. Capital M is the mass of the earth 6 into 10 to the power of 24 by r square. Radius of the earth value is 64 into 10 to the power of 5 whole square. Then you have to simplify this. You will get the 9.8 meter per second square. Acceleration value is acceleration due to gravity is 9.8 meter per second square. It means what? What is the meaning of this one? If any object falls on the earth, okay, what is the value of acceleration due to gravity on surface of earth? That is 9.8 meter per second square. Okay, that acceleration due to gravity on certain planet, on any planet we can find out the acceleration due to gravity. For example, if you want the acceleration due to gravity on the moon, then you write the moon mass and moon radius. If you want the acceleration due to gravity on any planet, then that planet mass and radius you have to write in this. That by that we can measure the acceleration due to gravity. Okay, students, right? If you have any query, write in the chat box. Next, acceleration due to gravity on moon. What is the acceleration due to gravity on moon? Acceleration due to gravity on moon. If you find out the acceleration due to gravity on moon, okay, you will get less value comparing with the earth. Okay, acceleration due to gravity on moon. Acceleration due to gravity on moon is 1 by 6 times of acceleration due to gravity on earth. That means what is the value of acceleration due to gravity on earth? 9.8 by we write as 6. Okay, that means we can write it as 2 3 ja 2 4 ja 3.4 by we write as 2 3 ja we write this we can nearly equal to 3 1 ja 1, right? What you will get, can you tell? Write in the chat box, students. Do it fast, I am waiting for your reply. 9.8 by 6, what you will get? If you divide this one with the 2, then what you will get? 2, this one is wrong now. Directly we can divide with the 6. 6 1 is 6, right? What's remaining at here? 6 1 is 6 means 3 will remains na? Okay, 3 8, 3.8. That means what you will get? When you will keep the point 38, you will get 1.63 something you will get, I think, meter per second square. Once you can do the calculation and yourself, and you can write in the third box, students, is it correct or not? Right? How much you got? Okay. Right. 1.63 is the right answer. Okay, now let us continue, students. This is the acceleration due to gravity on moon. Next, I am going to compare the mass and weight. Okay, what is mass and what is weight? Compare mass and weight. If we compare both of them, what how you will get? When you compare the mass, what is mass? Very important point this one. Mass is the quantity of matter present in a object. Okay, mass and weight. What are the differences? Few differences I will give. Okay, what is mass? What is the mass? Is means it is the quantity of matter present in an object. Quantity of matter present. Quantity of matter present in an object is called as mass. The mass is remains constant in the universe. In everywhere, the mass is constant. Right now, mass is remains constant. It will not changes from planet to planet or anywhere. Right? Mass is remains constant in everywhere. And the mass unit, SI unit of mass is a spring. SI unit of mass is kg. Okay, what is weight? Weight is the gravitational force acts on an object is called as the weight of an object. Gravitational force acts on a object. How much gravitational force is acting on a object? That is called as the weight. That means the weight depends upon the acceleration due to gravity. Weight formula is W is equal to force, gravitational force. That is mass into acceleration. But acceleration we write as acceleration due to gravity. Due to earth, acceleration is the acceleration due to gravity. Okay, then we will get like this. W is equal to F is equal to mg, we write. And the gravity, when g value, when you go from planet to planet, g value changes. That's where the weight is changes. Okay, weight of object changes from planet to planet. Right, when you will go from different places. Okay, weight of an object changes with the position. And the next one is the what is the SI unit of the weight? Weight is the force. Force unit is the Newton. Okay, so this is about the difference between the mass and weight. And next, let us go for the one more point. That is last one is the Kepler laws. What are the Kepler laws? Kepler gave the some laws. Okay, which describes the planetary model. Okay, how the planets revolves around the sun. The first law is that, what is the first law? The first law is that it is the law of orbits. All the planets revolve around the, all the planets revolve, how the planets will revolve. All the planets revolve around the sun in elliptical orbits. In which path the planets will revolve? In elliptical orbits. Okay, that means they will be go like this. For example, this is the location of the sun. This is the location of the sun, and the planets will revolve like this in the elliptical orbits. How the planets will revolve? In elliptical orbits, like egg shape. Okay, right. This is the one planet, we can take it as the Earth, whose mass is capital M. Right, this is the small m. It is, we can consider as the Earth. Not only Earth, all the planets will revolve around the sun in elliptical orbits. This is the first law. And the second law, let us go for the second law. What is second law? Second law is called as the law of areas. That is the line joining sun and planet. The line joining sun and planet sweeps equal areas in equal intervals of time. Equal areas in equal intervals of time. Equal intervals of time. Okay, what is the meaning of this one? For example, this is the one location. This is the line joining the sun and the planet. Okay, when the planet goes to this location, it covers this line. This is the line joining, right? Planet comes to here. Then another moment, their line also goes from here to here. It covers some area, right? The area covered is considered as the dA in time dt. At other location also in the same time, for example, the same mass, same planet is going revolving. This is the line joining the sun and planet. And after in the here in dt time, if it covers the dA area, who is covering the dA area? When the planet moves from this location to this location, this is the sun joining the sun and planet. When planet moves, the line joining sun and planet also moves. When the planet is at here, this is the line joining sun and planet. When the planet is at here, this is the line joining sun and planet. Means when the planet moves from here to here, the line joining also moves from here to here. This is covering some area. That area covered is the dA in time dt. At other location also, if you take the same time dt, it should cover the same area dA. That means the line joining the sun and planet, this is the line joining sun and planet. It will move along with the planet when the it will cover the equal areas in equal intervals of time. If in dt time, if it covers the dA area at particular location, at other location also in the same time, same area it will covers. That means we write as, it is called as the aerial velocity. Aerial velocity means area covered in time dt per unit time, that will be remains constant. Okay, right. And the third law is the law of periods. The Kepler's third law is that very simple it is. This is about related to the time period. Okay, square of time period of planet, square of time period of planet, square of time period of planet, square of time period of planet is directly proportional to the is directly proportional to the cube of cube to power of cube of average distance between sun and planet. This is the Kepler planetary model, right? What he is telling, the third law is that the square of time period of planet, t square, square of time period, t square, directly proportional to the cubed power of average distance between the sun and planet. You see here, between the sun and planet distance is not constant. Here distance is more, distance is less, right? You take the average distance. Square of time period of planet is directly proportional to the cube of average distance between the sun and planet. When the proportionality is removed, we will get as t square is equal to constant into r cube. According to third law, that is r cube by t square is constant. R cube by t square or otherwise t square by r cube is equal to constant. This is the third law. Constant into r cube. Okay, right, students. This is the time. What is time period actually? Time period, square of time period directly proportional to the cube to power of average distance between the sun and planet. These are the Kepler laws. Time period means what? Time taken to complete one revolution. For the planet to revolve around the sun for one rotation. If the planet starts at here, it completes one rotation. For the time taken is called as a time period. It starts at here and again come to this location. Further some time required, that time is called as a time period. Okay, right, 5 minutes I will continue. Next one is the equations of motion. Equations of motion. Okay, what are the equations of motion? You know equations of motion that we derived in the motion in a straight line, right? Then what are the equations of motion? For example, if an object is moving with initial velocity u, okay, initial velocity of an object is u, initial velocity of an object is u, and final velocity of an object is v. Object is moving with some acceleration a, okay, object is moving with an acceleration a, and it takes some displacement s in time small t. Then at that moment we write the equations. There is some relations are there, that are the v is equal to, equations of motion are the, first one is the v is equal to u plus at, v is equal to u plus at, and the second one is the s is equal to ut plus half at square, and third one is the v square minus u square is equal to 2as. These relations we derived in the motion chapter, okay, by graphical method. You learn properly these equations. For example, what are the conditions for the freely falling body? In case of freely falling body, conditions are what? Conditions for freely falling body. If an object is freely falling on the ground, conditions for freely falling object. When object is freely falling, then what are the conditions? If object is freely falls on the earth, okay, object is freely falling on the earth. When object is freely falling, we are not throwing that one. Initial velocity 0 you have to take. u0 you have to take. It is falling due to gravitational force. That's where acceleration becomes sg. Velocity increases. And displacement, for example, it is falling from h height. You have to take the displacement equal to height. Okay, the time taken is the t. And when final velocity, it strikes the ground with some velocity, that is v. V is v. Just the simple condition is that initial velocity you should take as 0. Okay. Right. Condition for vertically projected, upward projected body. In case of upward projected body, you have to throw with some velocity. Itself, it never goes in upward direction. You have to throw. Initial velocity u. While going, its velocity decreases, and finally its velocity becomes 0 after if it reaches the maximum height. Okay. Then initial velocity you have to take as u, and acceleration you have to take as minus g. If it reaches the maximum height, then at the maximum height its velocity becomes 0, because further it never goes up. Its final velocity becomes 0, and its displacement is again equal to some height. The time traveled is t. Okay, right. These are the conditions. These conditions you have to apply while solving the problems. Okay, students. Okay, thank you to all. I am closing due to some work. We will discuss later. Remaining. If you have any doubt, you write in the chat box. Have some value. You remember its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the see here. Some value. You remember its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the see here. This is the quantity of matter present in the mass and weight.